All right. We're going. Hey, welcome. We could check. Is everything running? YouTube looks good. LinkedIn, does LinkedIn look good? Hey, everybody. LinkedIn also. Let me hear you if you're here on LinkedIn. Yes. Seems like we're live on LinkedIn. Say hello, say hello. Welcome. Welcome, welcome. Welcome, welcome. Today we are going to look into something. Today we're going to look into a new course that I just released. RAG, GenAI, with Elasticsearch, with LlamaIndex, with Ollama, and using a Mistral model. And basically, what I'm doing there is I'm looking here into having PDF documents. Oh, yep, Mark. Nice. Thanks, Mark. Thanks for the reply. Hey. Yeah, welcome everybody. I'm having here the Python that is taking the data, putting it into FastAPI, into an API, just an upload of the file, and there we're doing the whole processing and embedding and so on, and putting that into Elasticsearch. And the embedding happens with the Mistral model hosted through Ollama. So you could basically also switch this out with ChatGPT, but I wanted to build this locally for everybody first. And then you, on the other side, have a user interface with Streamlit. So basically here you have a chat user interface where we can ask questions to the documents, right? And that is the main thing. I always say everything is data engineering. Always say 80% of AI is data engineering. And it's a bit with that the same, that you actually have to understand how to set everything up, and the actual AI part, the embedding part, is also kind of a engineering problem. And then you have your embedding in the Elasticsearch store. And I can show you exactly how this works here. I can show you this in this session. So I see a few people are here. Hi, welcome everybody. Say hi in the chat and let me know that everything works and that you're here. And for me, the interesting part would be, have you already worked with RAG? Have you set up something? That would be interesting to hear. Because I think a lot of people actually benefit from a project kind of like this. And I can show you what I've done. I've went on and I created a bunch of PDFs in our Docker Compose file, in our GitHub. And for instance, I created with ChatGPT a bunch of like data engineers that might sound famous or familiar to you. Also, this is basically, as always, the name in there, and then we have the role, and we have kind of a profile text. And this is with ChatGPT generated technical skills, and then experience and projects. And yeah, this also includes awards and interests. And basically these things you ingest and then do the embedding with Mistral. And there's actually a LlamaIndex part in there. I can show that to you. Here where basically the data is coming in, it's getting sent through Python, put into the FastAPI as an upload PDF URL, and then went into a local storage on the container here for FastAPI, and then extract the data, create a JSON, and then index this or embed this with LlamaIndex, and that uses also Ollama. And then Elasticsearch, and on the other side Streamlit also then queries the data from Elasticsearch from the vector store and you are then getting a good result. And that's the whole thing. It's actually pretty neat, and I can show you how the documents basically look then in Elasticsearch. What you're going to have in Elasticsearch is you're going to then create a bunch of documents for each person, right? Because you're splitting the whole document, embedding a whole document at once, a whole PDF at once. That doesn't make sense. You always want to shrink this down so you can actually find the important information better. And then let's see. What I have done here is let's look at a single document. And in there I have the actual metadata of the actual content here, right? The information that is from Elasticsearch, and then here below we have the student CVs. That's the raw text that will then, once I'm on the wrong side, once we retrieve it, we're going to feed this into the LLM, and also we have the vector here to find the right information with semantic search. And we have some metadata and name field, Montgomery Scott. And that's the idea here to build. So the data comes in here, right? Then the text gets extracted, gets put into a JSON format because Elasticsearch needs a JSON. And then we're going to split this into multiple documents and put this in here. So, and that whole thing is exactly the same always. You're doing the same thing for every GenAI or for every RAG application. Taking data and then embedding it and then putting it into the store with the actual data and the vector. And then you're just searching for the right vector depending on your input. Right? So questions around that. What do you think, guys? I put this actually here in learndataengineering.com into the our new AI engineering track. I think I pressed the wrong button. Here. And in here, there is now, we have the GenAI embeddings topic. Then we have the semantic search topic, and now the RAG project. Yeah, that is what I'm talking about. That was the last one that shows you how semantic search works, because you need that for RAG applications, and that one is for embedding. Yeah, you want to see how this looks then in the UI? Here, I can show you. Let me refresh the UI before I show you this. Okay. So the idea here is you have your student chat, CVs, and here you can ask a question, and we can filter by person, which means we're filtering by the metadata name. For instance, here Montgomery Scott. And as I said, I have multiple people in here. And then we can ask a question. Well, Thomas asks here, like you said, AI is 80% data engineering. Could you highlight which are the core parts? Exactly this here. This whole thing, right? This whole pipeline, beginning from, okay, I'm going to create let's say a door where the data gets in. That is my API here. Through extracting the data from the PDF. And that's actually very simple with PyMu PDF. It's just a Python package. And then turning this into a JSON. That's all data engineering, right? It's all data engineering. There's nothing AI here. Nothing. Absolutely nothing. Then you have the part where you create a text with JSON, or create a JSON out of the text. Let me show you the code. It's like, this is a joke. Let me show you. It's like, come on, open up VS Code. Here. It's basically the part where you're doing here. Let's see. This is this. This is this. In this here, basically you're extracting the data with fits, which is PyMo PDF, and then below here we have basically a prepare function, and that then generates us the JSON, and that uses our model again, right? You're creating here a chat, or you're using a chat with Ollama, and like that is all. It's super simple. Here this is already chunking, but the whole ingestion pipeline, that splits the text into chunks, and that does then the overlap. The whole thing is so simple that you're doing. And here we have, this is already our data. Now, of course, in the course, I'm going very deep into this and explaining every step. But here, prepare JSON. Here, extract text. Actually, I didn't explain this 100%. This extracts the text, right? And then this prepares the JSON. So this is this part. And then all you do is you take your JSON, and then you create a document, and then you create here a pipeline with LlamaIndex, and you feed that into the pipeline, and that's it. And that uses here Ollama as the embedding model. So this whole process is, where's the AI here? Where's the science here? This is only engineering. This whole process is only the engineering part. Then if we go back, right, let's look into the other parts here, right? Where's the AI part? So this uses Ollama, right? So this just uses an LLM. You're not creating an LLM, and you're using LlamaIndex, which this is still engineering, I would say. Sentence splitting and embedding. This is a bit where you need to do optimization. So you actually later are able to find the right data when you ask a question. This, you could say this is science, but I'd also argue this is still engineering. And then you have your Streamlit app, and that Streamlit app has here the part where you query the data. Ask a question, query the data from the vector store, putting it into Ollama and return the answer. Where's the AI part here? It's like people make a huge mess or a huge fuss out of this whole thing. It's not. It's so simple. I have trouble differentiating between data engineering, ML ops, ML pipelines. I think they're all under the same umbrella. Yeah, people make a lot of, turn this into this huge thing. Of course, there's a bit of a difference between the typical machine learning and this part, like this project here in RAG. Very often with ML is that you actually train a model. We're not training here a model in the whole RAG application, right? You're using embedding models that are already finished, and then, or you're basically just using them. It's not like you train a new model. That's a different part. And that's also where ML ops comes in very often, that these are applications that are doing where you train a deep learning model or where you train a classifier and so on. And you're running the operations for the training as well. But with this, it's not the case. ML pipelines, it's the same thing. It's the same umbrella. It's all, I would say this is all engineering. It's not so much actual the ML, the machine learning, and so on. Right. And that is the same here, the same question. Can you embed AI on top of your data warehouse so that people can query through prompts? What are the pros and cons doing that? Stack BigQuery, DBT, or AWS? Of course, the process is a bit different, right? Because you can't, like in this, we're using semantic search. Right? So when you look at how this works is here, the idea with that is you have that vector here, that gets created out of your text that you're sending in. Right? And then when you ask a question, it's trying to find the parts in the text that are important. Like, for instance, I can show you an example here. If we ask the chat here, the student CV, if we say, okay, we want to search here for Montgomery Scott, this will then only get the documents from Elasticsearch for Scotty. And we ask, what experience, or how has Scotty? No, that's actually a bad example because we're not using semantic search here. We need to go through, not filter by person. Let's use the debug mode. Let's look at Scotty's CV. So if we want to search something in here, right? We want to go and find, let's just use this here. Dyson Sphere long-term storage benchmark successfully proved that a transporter buffer could store data and a human engineer intact for 75 years. So we could ask here, we could say from a question, who successfully proved that a transporter buffer could store data. Right? We could ask this as a question. And of course, I'm using Mistral here on my machine, so the answer will actually take a second for the generation. But I can show you exactly what is going to happen here next and how this looks. So we're asking basically specifically for a question, or that sounds, what we're questioning that is semantically very likely to what's actually in there. Right? And so let's quickly wait. I don't know why this is, like, it was faster here. Okay, so it then gives us here Montgomery Scott because it successfully validated a transporter as a potential archive storage solution, though it does come with a slight temporal disorientation. I don't know. So this, I think this is a hallucination actually here, because this is not in the text. But we can now look at the chunks that it retrieved here, right? And we can see who did it retrieve. And the problem here is with the precision is not very good. So the first chunk that was for carat race, that was not what we wanted. Then we had the second one here, score 0.778, Montgomery Scott. And then we can look here, okay, validated transporter as a potential archive solution. So this one is actually good. Excelsior, what do we have? This is also not him. This is also not his chunk. Okay, so it actually took out that just from this chunk that he, or is that Dyson Sphere in there? I think I can't search here. I'm not 100% sure. Did I miss something? I know, I just used a transporter buffer. And here's actually transporter as the archive solution. So this actually took it out as a bit from the context. And the whole thing with the temporal disorientation, that is a hallucination. That actually texted it to our text or added it to our text, which is not good. And that's the whole idea. Now, if you say, okay, I want to put this on top of my data warehouse, you can't use the semantic search capability here, right? You need to go something where you do like a filter, or in the background you create SQL queries with a LLM that actually then fires off the queries towards your database and gets you the data. But that you can't do with your data warehouse. How do you score your pipeline to give you better answers each time? That is the problem. You need to do this whole thing, how you get better answers. This depends on your embedding strategy here. How do you split the sentence, or how do you create the chunks? How is your embedding strategy? What model are you using for the embedding? That actually determines the output, or the precision of your queries. Once this is embedded, you have no chance. You need to re-embed everything. You can't change the embedding model, because if you change the embedding model here, or if you change the embedding model in the Streamlit, this doesn't work anymore. So before you actually then set up your whole, or embed your whole pipeline, or your whole data, that's the right word, your whole data, you actually need to figure out what gives me good results. And that is actually a trick. And for that, of course, what do you need? Engineering. So the whole thing is actually an engineering problem, and not really a AI problem. Because the AI, where's the AI here? The AI, again, that's our Ollama. That's our model. And that is pretty stupid. So the way how you format your question, how you split the question, how you add metadata to it, that is the important part, and not some kind of AI magic. Right? And the scoring, that is happening automatically here. The score that we see, I don't know why this has a score of 1. Strange. But that score, that actually comes out of Elasticsearch. And that's what these tools always do. So basically 0.2, that's terrible. 0.0 is terrible. 0.44 is terrible. 0.78, that is a good score. And we can actually, we want to try something. Let's see. Where's my embedding? Because I have a playground. For that, let me go. You can play around with that here. Yes. Embedding playground. And we can, let me just go in, and we're going to take that here. Boom. We're going to put this here as the expected text. And we're going to, I'm not sure if that works, and we're going to use here our user input. Let's see how good actually the result for this is. Well, this doesn't get us good answers here. So what would happen if we just, because this is a demo, so this is not perfect, but I think you get the idea, right? This creates the input vector, this creates the expected vector, and you compare these vectors, and then that gives you the similarity. And that's all that it is. So if we just delete everything else here, boom, let's see how the similarity is there, 0.06. I think there's a little bit of AI still involved to score the model, to throw better answers, supervised or unsupervised. That whole thing, that is just basically vector comparison. There's no AI in there. There's no AI in there. I explained this in my, in this. here in this hidden foundation of AI. There is absolutely no, the vector scoring, that is just a cosine thing. So that is absolutely simple. There's no AI in that. And that's why this is so fast, because it's just a mathematical operation, basically. Yeah. And that's the cool thing. Now with this, as you can see, this actually retrieved us some good information. So it's a Scotty. So what could we ask as well? Like, let's look at something that has maybe a few. Dupe Spark, Airflow. There's another one. Does he have Spark in there? I think this is a bit. I'm not sure what to ask here again. And the cost. How do you measure the cost? The cost of what? That's the question. The cost of what? In this. Which cost? Come on, LinkedIn user. Okay, I'm going just. What competence Scott has? This is for this. Okay. So if for that, what we should do is we should use here a filter, right? Boom, boom. What data engineering? Oh, oopsie, you don't see it because of that. Skills. Does Scotty have? Because I'm just using Scotty here because I filtered already by the name, right? Debug mode. Okay, let's use the debug mode. So let's shoot this off and let's wait for the answer. And while we're waiting for this, the idea is with the cost. We were talking, LinkedIn user asked here about the cost. Now, how is the cost usually measured? The cost, whenever you are working with LLMs, the cost is always the tokens, right? And the tokens is when you go over here and when you create your user input, when you ask a question, the question has a bunch of tokens and the expected text also has a bunch of tokens. Right? And then this is what you see, for instance, with OpenAI and all the other platforms. When you use the API, you're going to be paying via tokens. How many tokens input, how many tokens output. And usually then this will go in there, boom, boom. And then, yeah, this. Okay, this actually has a good similarity right now, of course, because this has the actual text in there. But I think you know what I mean. This is how costs are measured. Right? The question, can this be used to query and look for data across multiple CVs? Of course, yes. You could, and that's what I was thinking of. What do we want to ask here, Ramya? What skills or what do we want to find? Ask me a question. Let's ask it a question. The only limitation what I have done is for the part in Streamlit is I went in here And for the Streamlit app, I limited actually how many documents this is going to return. Where did I do that? Here. Oh no, this is with a filter. I think use filter else. Yeah, I limited this here only to return 5 documents. So I should have actually made this bigger to get more information, but I didn't want to go over from the token wise, I didn't want to go over the max that Mistral has. So Ramya, say something. What do we want to ask here? While I wait for you, Mark, we can't use this dataset for 2,400 resumes here. We're not going to do that here. This is also like, I don't know if this actually would give us a good result. Then, it would theoretically be working, but from a perspective of actually the embedding of these documents, the embedding takes a bit of time here on this machine. So that's not as easy to do. But thanks for the link. I'm going to look into that data set. That's actually good. Cool. Cost is model deployment costs. Well, model deployment costs, I mean, if you're hosting this yourself, what's the cost? Nothing. And if you deploy this on or use ChatGPT on OpenAI or wherever, nothing. Plus the tokens, yes. Memory and storage, of course, that's a point. Memory and storage for the vectors, although you can easily calculate this, because when you index this, you know how many dimensions did I configure this here? Let me quickly check. I think in that I actually didn't. One sec. Is that configured here? 200 model. I think I didn't actually get this in here. So we would need to check how many dimensions actually the Mistral model delivers. But when you look in here, you know how large that vector is, right? You know how much space this vector is going to take. This whole thing, how many dimensions you have, and then at the end you see this is a huge vector, right? And then it's just a number of, okay, let's calculate how much space this vector is going to take. I think that is not a big deal. That is pretty straightforward. Yeah, Ramya, I know, asking which specific CV has the closest skill set we are looking for. So which skill sets are we looking for? Let's just ask, okay, I need someone, I'm looking for, let's ask, who has skills in Python, Spark, Scala, and has a military background. So let's see. As I said, the problem is with that setup here, I don't want to start everything over and go into the code and build the Streamlit container here again, the Streamlit image again. But I should have actually set this up to like 10 documents that it returns. Let's see. While we wait for this, how accurate will it be? Oh, okay, we're already here. So it says, oh, okay. Provided context does not mention any individual with skills in Python, SQL. So that's what I mean. Like when you see the scores here, the scores are not good, right? 32056, it's terrible. 058. So this actually has a bit, but no. That's where the problem here is. Always the precision of getting the right data. That is the important part, and that's where this actually sucks. So most likely you're going to use here more with metadata. You're going to maybe chunk this a bit smaller, or making smaller chunks, maybe extracting more data out of the text and then putting this into a separate section. So that's always the problem here, and that is the actual difficult part, to find that out. But is that a AI topic? No, this is an engineering problem, right? Now, no, it's not because shit, you're right. Whoops. Okay, let's do this again. Didn't see that I had the filter on. How accurate will it be when it comes to calculate metrics to aggregate the data? Not sure what that means. What does this mean? Aggregate the data. This thing, metrics. The idea here with this, and we can see this here. Let's quickly wait for the result. This doesn't really aggregate the data, right? Explicitly also having military background. The individuals listed are Carol Thrace, Liam McGivney, and Jeffrey Lebowski, and Montgomery Scott. However, the context does not suggest military background regarding them. But what did this actually return for us? Not good. Okay, here we have a few skills, right? Spark. But that's not a good score. Even worse score. So that is actually our problem, right? In this, it retrieves us chunks, but the embedding wasn't as good to actually give us good results, right? And that's where you actually have to work on the embedding. But again, that is not a AI problem. That is actually a problem from here, from the embedding. And that's all this does. It takes that data, this, and that feeds it to Mistral, and Mistral then creates us an output. And because the score is so bad, the problem is with that kind of a question in this. Let's just ask again. Let's ask again about the military background. Let's see if we find something. But I think you get what I mean. These things here, this, no, not this. This here, this, and this part here. Well, this actually not this here, this red part here, that is the most important part, right? How are you doing this? There are ways where people actually combine these two, right? You have the metadata, like we had here with the name, that you actually do a search for both options. You first search for the metadata, where you would say, okay, I'm creating metadata that has the skills in there or has the tools in there, a list of tools, and then I'm searching for documents that have these tools mentioned. That would be actually a super easy fix to get better on the precision. And also it could be that, okay, the better option would be to have smaller documents here or have more metadata embedded in the documents. That's the thing. But in this project, I wanted to show how easy this actually is to set up, right? Because once you have set everything up, then it's just a tuning thing. Then you just need to, okay, this is my data. This is how my data looks. This is what people usually query, and how can I make this a better fit? And that's all. And yes, that is a big problem, because this is an engineering problem, because you need some kind of a tool to actually get to a good solution. Well, let's see. Did we ask a question? Based on the provided context, it appears that Kara Thrace has some sort of affiliation with a military-like structure. As Colonel Flight School, which suggests has a military background, and also Montgomery Scott's primarily associated with Starfleet, which is more exploration, peacekeeping than military. But you can see it retrieved us a few chunks here. Were these chunks good? Terrible again. The score not good. And so, not really happy with that. But I think you get the idea. Of course, if you ask this question again, because our precision is not good, it will retrieve different documents, and then the information will not be as good. Yeah, but if you want to try, give this a try, and you want to learn data engineering here in my Data Engineering Academy, I have that in the new AI engineering track for everybody who just joined. And in there, I always say it's all data engineering, and I have a part of for embedding. I have one for where we are doing semantic search. That is the basis for RAG, creating the embeddings, writing this into a vector store, and then querying this out, and then this here. And I'm already working on the next ones here for an agent, where I created an agent that that's connected to Slack, and you can actually ask the agent a question and then it returns you the information. And the next part is with MCP, where the agent is connected with Slack, and then has a RAG in the background that then tries to find the right data, sends it to the LLM, and gives it to Mistral to answer, and then the Slack agent is going to answer you. So these are the things I'm working on. This already works, and this already works. And now we have the GenAI part here with the RAG part. And we have that. More questions around this whole process, around the project. As you can see, this is just a simple document store that stores the vectors, and all vector stores work the same way. It's literally always the same thing. You store your actual data and you store the vector for that data. If it's Qdrant, Milvus, or Pinecone, it's always the same thing. And again, it's all engineering. I haven't done anything in all these projects that actually needs me to understand AI or create a LLM model or something. Just you're using it. Some models are better for this, some models are better for others. That's where you need to do a bit of research when to use the right model. Mistral here is maybe a bit big. I could also use a different model to get faster answers. But yeah, this always depends on what you want to build and what you want to do. Yeah. Yeah. what job I am in. Well, Leon, it looks like you're new here. I'm a educator. I've been working in data engineering for over 10 years, and then I started my own academy, and since then I'm having Learn Data Engineering here. That's my platform where I do courses for people. I have the academy with over 30 courses and projects, and I have a coaching program where I basically help engineers get better, or become better engineers, find new jobs, and so on. And a lot of stuff in there. The basics that you need, platform pipeline design stuff, fundamental tools like Spark, Databricks, Kafka, and so on and so on and so on. And then on all kinds of platforms, AWS, Azure, GCP, projects that you can, run. I just saw here this. We actually need to remove this new part. Thanks, Mark. Loved the demo. See a little bit differently. I still think we need mathematical understanding to tune these models to give better results. Where? I don't know. Look into how embedding works and about cosine similarity and how that works with the embedding models. And otherwise, I don't see any mathematical understanding that we need here, because the LLM is as good as the LLM is. And I'm a hardcore engineer, so as I only have a hammer, I see everything as nails. But and to tune these models to give better results, that's more of a term of creating better embeddings, not the model, but basically, let me show you something, Mark. Because when we are looking into what I have done here with the embedding, and I've done something very simple. Let me quickly find this. Here are the documents. When I create the documents here, right, all that I do is I'm giving this document the text, which is the input text from the document or from the PDF, and I'm giving it the metadata that is the name here. These are the only things I'm doing, so that it then chunks it into smaller documents and has an overlap, of course, and then it embeds it with Mistral. That is the only thing I've done here. And when you want to optimize this, then you need to optimize this part here, and not just throw everything in and hope that the embedding works. You need to work on this part. And that's why I marked, where is it? That's why I marked this part here. And of course, there are different models that you can use. That makes sense to look into, but generally, I think that is an engineering problem. So I disagree here, but happy you loved the demo. When learning Databricks with you or any tool, is there any access provided by the platform to work with, or is something we need to figure out by ourselves? I mean, for the price that I have the Academy for $260, I can't give you, I can host Databricks for you. The thing is, they have a free plan, and you can just use the free plan, and it costs you nothing. So with the community edition that they released. And I think a good engineer needs to understand how to set something up. For the Databricks project, for instance, that I have in the Academy, I show you exactly what you need to do to set it up. So it's not a big deal. Yeah, but that's that. I know some people host it costs $1,000 a year to learn this, and they give you access to the tools. But like for the amount of, like, I try to keep the price for the academy very low, because as you can see here, because the academy costs $264 a year, or $480 for unlimited access, and for that, that's possible, right? Ibrahim says, I think the selection of the LLM model that can translate the natural language processing to query may make some difference, but I also agree there is no mathematical needs here. Yeah. Of course, the model always some models are very good, have a very fast inference. Some models will do the embedding better. Same, you already figured this out. Maybe some example shows learning could help here. I mean, selection of embedding model. Yeah, of course, that's what I mean as well. That will help, and that's where you need to do research, right? That's where you need to be a good engineer and understand, okay, what are the goals actually that we want to solve, and what's the data looking like, and how can I build the part in between that works really, really well. And that's always the problem. I don't see this as the big AI problem. It's just you need to pre-process is the right word. You need to pre-process the data well enough so that you can then have that functionality. And that pre-processing, that is where you need to have experience, where you need to be a good engineer. That's what it needs. Yeah. Of course, by the way, I also have a different, like I have another, in the course, I have an example how this actually looks in the real world, what companies do, but I'm not going to go over this here now. But usually it's a bit more complicated than what I've set up here for you, to give you the fundamentals of RAG and experience this and play around with this and maybe improve this. Well, Daniel, the idea. Okay, let's get this here, Daniel. Talk a bit more about embedding. The idea with embedding, and you can also play around with this. You can just go to learndataengineering.com, right? Go to the website, and then scroll down here, and here are these playgrounds, and that's what I've set up here, right? And this is basically, this is how the embedding works. Let me get to, where do I get here? What's the best place here? Oops, that's not what I want to do. Let me make it like this. So the idea with the embedding is always the same. And the transformers, there are a bunch of transformers that you can use. Here I used one that actually works in the browser, right? And the idea with that is always very simple. You have a text, and with the embedding, you create a vector out of this text. Now this vector here has 300 and something. Here, this uses the Xenova All-Mini L6V2, how's it called? Transformer. And that has 384, maybe I'll make it bigger. That has 384 dimensions. And that's that here, right? That's then the vector. And then at the other side, what are you doing here? When you look at the rough Python code, all you do here is you do the same thing. You have your embedding, and then you create the embedding. You create the output basically. And this creates a bunch of vectors that you actually then well, combine is the wrong word. You basically combine to because this would generate you 384 vectors, and you actually create a single vector out of this. And then all that you do here is you do a cosine similarity between vector 1 and vector 2, and then you will get a similarity score from this, and that's it. That's all that the whole shebang is. It's not really a big deal. You just need to understand which which embedding or which transformer do I use, and that's it. And that it's the thing is always the same, always works the same way. And at the end, you're just doing a cosine similarity, and that's why this is so quick. The important part is to basically look through all the documents that you have, and then feed that to the LLM, and then get the information back. And also with that, with the Streamlit part here, the actual getting the right chunks is super quick. The getting the answer from the Mistral model, that is what takes the time. Mark says, very clear and to the point. Thanks, Andreas. Welcome. Would you be interested in discussing what those folks at Cetaris are doing in a later session? Of course. Of course. I have heard about Cetaris. I'm already looking into this. I'm working with Datacated on a post about Cetaris. And was it yesterday or the day before yesterday where they had a live event, and I actually looked into this for a few minutes. It's quite interesting, Cetaris, yeah? All right, guys. Thank you. That was, if you want to learn data engineering, check out the platform. It's like I have so much stuff in there. It's crazy. LearnDataEngineering.com. And if you have questions, put them in the chat afterwards. I'm going to look at it. But also we have a post about this on LinkedIn that you can just put your questions in there, and I'm going to answer them. Thanks for being here. I hope you had fun. I hope you learned something. And then see you next time. Bye. Where is it?